Hi there, and welcome to episode 4 of the BCIT Technology Teacher Education 5060 class Boombot project. And today we're going to take a look at the QRD1114 reflective sensors in the edge detector part of your robot and how to use them to create a line following robot. Now, this is the previous generation of Boombot, doing this from a couple years ago. And you can see we've put a piece of electrical tape down on our white shop floor. So we have a dark line over top of a white surface. And we've got a bunch of robots racing around in a circle. And it's always interesting to see who can optimize their code to make it go around the circle the fastest. Oh, now we're showing off a few other things that it can do. But yeah, there we go. So line following, coming around in a circle here, and we're going to use your edge detection board to go ahead and do some of that. Alrighty. So what do you need to know in order to make that happen? Well, you need to know a couple of things. First of all, about the QRD 1114 sensor. Now, you'll recall putting them together when you built your mini sumo, when you built your Boombot, and they're right up here in the nose. Okay, and there should be two of them, and they should all be hooked up. And if they're working right, just turn that around and notice that with my camera, I can see a little light shining right in there. Now, you won't be able to see that with your naked eye. You might be able to see it with your cell phone camera. Break out your camera and give it a try. Probably a webcam or something like that will pick it up really nicely. And you can see that there's two slots on here, and one of them has this little infrared light shining on it, and the other one is just kind of black. Well, that's going to be our receiver, and one of them is transmitting light, the other is receiving light. And if the signal's bouncing back into there, that signal travels up this cable right in here. And you'll have to be able to take your robot and pop the top on here and just double check to make sure this is working by taking a look in underneath right here. And your cable should be hooked up right into the port like that. So that's why I say make that about 25 or 26 centimeters long. And also pay attention when you hook it up. Okay, you'll notice that there is an extra pin on this connector right here, and the camera's having a hard time focusing on that. Let me just unplug right there and flip this around so maybe you can see a little bit better. And focus right here, camera. Well, that's what it looks like for those of us who forget to put our glasses on in the morning. I'll put that down a little bit. That should hopefully find its way to focus in there. And anyways, this is a 4-pin connector, this one coming up from the edge detection board because we only need 4 pins. But this is a 5-pin connector right here. And the reason we have a 5-pin connector is because we're also going to use this connection for running our joystick board on here in a later video, and we're going to use the joystick to drive the robot around. So anyways, that has to be all hooked up correctly, and you have to make sure that the ground plus 5 volt and your 2 signal lines in there are hooked up correctly to the ground 5 volt and signal lines on your edge detection board. And that's why all of those signals are pretty clearly marked on the boards. So if you're having problems finding it or something's not working and you're not getting a lovely glowing light out of there, well, make sure your robot's turned on. I'm turned off right now. Then you're going to have to go back and double check some of your wiring. Okay, so if you've got all that hooked up and running properly, let me plug back in right here onto the Arduino, that lovely sound of a device connecting over USB. Boots up, flashes some lights at us. And let's go back and talk a little bit about what this QRD 1114 is. There's a couple different parts that could do this job. The OPB 706A is pin compatible replacement, just costs a few dollars more. But basically what we've got is you can see that here's a picture of your chip. This is on the data sheet right here. And you can see that we've got a schematic right down here? Well, we've got an LED on this side, and it looks like a phototransistor on this side. I want to make sure that I've got it right. Yeah, there we go, phototransistor. You can sometimes get photodiodes in here, and the phototransistor and photodiode are kind of like, well, the phototransistor is basically a transistor, except whereas normally you'd have a base coming in right here, okay? The base is actually, you can think of it being replaced as a photoelectric cell. It's a bit of a simplification, but when light comes in here and hits the base, that turns on the transistor and it allows electricity to conduct through the transistor. Now, not all that much electricity, so we have to be careful that we don't overload it. We'll talk about that in a minute. But when light comes from the LED and bounces back into here, the transistor turns on and electricity can flow right through there. And the data sheet tells you which pins are which. If you've followed the schematic for putting this together and you've plugged everything in the right hole and you paid attention to the pin 1 indicator, that little dot, and you put it in the right place, these should all be working just fine. Okay. Uh, the data sheet's useful because it gives us some maximum ratings on here. So for instance, somewhere in here, we will find the continuous forward current from the light emitter can handle 50 milliamps. So you only want about 50 milliamps heading through your LED maximum. So that's why we've got a resistor leading up to that. And then your sensor is, where are we here? Your maximum voltages that you can have on there. Forward sensor, emitter, collector breakdown, milliamps, collector current right here is typically around 1 milliamp. So what we're going to do is we're going to make sure that we've got that turned on. Okay, now further down in the chart, it gives you some more information on the data sheet. And this chart right here is a really useful one because it tells you where you're going to get your maximum reflection. Okay, you'll notice when you take a look at the board right here that we've 3D printed this part. And when you look at the CAD, this is all specifically designed so that your QRD1114 rests about 1 millimeter off of the piece of paper that you're working on. Well, 1 millimeter happens to be somewhere in the neighborhood of 50 thousandths of an inch. And so right in here, we're working at the peak range, okay? As the device starts to get further away from your paper, all of a sudden your efficiency goes down and all things start to look really, really dark. Okay, so useful information in data sheets. Always spend some time taking a look at the data sheets for projects. Okay, now let's take a look at it, how we use that data sheet in our schematic. Okay, so here is our Boombot schematic, and we've got a couple of QRD 1114s in the edge detection board right down here, Q4 and Q5. Now we've got let's see, where are we right here? Let's just take a look at this one in particular right here. Here's the LED coming right in here, and here's the phototransistor. We've got our 4-pin connector that comes up here and plugs into our 5-pin connector because we'll use that extra pin for when we hook up the joystick board later on. But for any sort of sensor, you're going to have power and ground coming down here. And this line right here is going to come in, and this line is going to be our power. It comes in, sorry, that's going to be our ground. This line is going to be our power. It's going to come in right here and come down here and energize our LED. Now there's a 180 ohm resistor right there. That's what we use to limit the current that comes down through the LED, and then the LED current comes right back out here and comes right back out on the ground line. The LED is just that, it's an infrared LED and it turns on, and just because we can't see it doesn't mean it's not turned on. Use your camera to check it out and you can probably see that glowing. Okay, that's in the same frequency of light that's used for your infrared TV remote control, and it's what we call the near infrared. It's just a little bit longer wavelengths, little bit lower frequency light than red light. Okay, our visible spectrum goes from red all the way through up to the blues. And when you go beyond blue, all of a sudden you're now into what we call the ultraviolet range because your intense, not your intensity, that's not the best way to say it, your frequency is beyond the visible light. It's ultraviolet. The wavelengths are shorter. Down here, the wavelengths are longer. So anyway, that's just the infrared light that we're dealing with. So it comes down here, and from our positive side, we energize um, the two LEDs on our edge detection board. Alrighty, now the plus 5 volt line also comes down here, and where's that plus 5 volt line gone? Right here. Comes through a 10K resistor and a 10K resistor right here. And the 10K resistors lead in to the collector of this transistor. Keep in mind the base is sitting open here, and the base is the equivalent of getting a signal when light bounces back into it. And here's our emitter right here, and our emitter goes down to ground. Now we've used this kind of configuration with transistors before a little bit, and basically it's a voltage divider. When light is hitting right here, this is like a switch that's turned on, and electricity will flow through here, causing a voltage drop across the 10K resistor, and we'll be able to measure that voltage drop as an analog input. Okay, now when no light is hitting the transistor, or not enough light to turn the transistor on, then there'll be no current flow through here, and there'll be no current flow through here, and therefore no voltage drop across here. So this will be high when no light is hitting it. And when lots of light is coming through here, the equivalent resistance of the transistor should be very low. So we should come back here, and on an analog pin, we should have a low reading. So we're going to get the signal to switch back and forth between high and low, depending on whether light is being reflected back into the sensor. And the same thing down here, it's just the same system, but it reports on a different pin right here. Now those pins come right up here, and you can follow where they plug in right here. They come back in and they connect to the control board, to the Arduino on pins A0 and A1. So what that means for us is that in our code, last time out we added a couple new constant ints, a couple new definitions. Last time out, we added the trigger pin and the echo pin for the ultrasonic rangefinder. Well, this time we're going to add two terms, left edge detector and right edge detector. I don't know why I always call them an edge detector. I guess because we detect the edge of the line with them. You can detect the edge of a board in the context of mini sumo. You know how there's a white ring around the outside of a sumo board. That's so that the autonomous sumo robots can see that edge coming before they drive off of it, because they've got reflective sensors pointing downwards, and they transition from a black to a white. We're going to use this for line following. But I still call them an edge detector. You could call them a line detector if you want it. And on my robot, I've got the left edge hooked up to pin A1 and the right edge hooked up to pin A0. And I think if you've wired everything up correctly, yours should be the same. Might be possible that they're backwards, but we're going to test for that first, and we're going to test their operation first. Okay, so we've got that put into our code. We've saved it with a new name up here for line following. Don't save it over top of stuff you've done before. Because these are both going to be inputs, we don't have to set up any pin modes in here unless we wanted them to be an input pull-up. We don't need that because we're going to use the analog read command to read them, and analog read takes care of setting the pins for us. Okay, so now this is running away for us, and one of the cool things about the new Arduino IDE 2.0 is that it's got the serial monitor built right in here, and you can see your code. So you can see that as the loop is running around here, it's printing left edge. It's going and it's doing an analog read of the left edge pin. I already forget whether that was A0 or A1, and then it'll print right edge, and it'll do an analog print of the right edge. And here you can see that we're getting readings of 29 and 27. Now that makes sense because the sensors are sitting right over top of a nice bright white piece of paper. To give them a good test, lift them up in the air. Okay, because remember how we were taking a look at the data sheet, and these only work well, they work best when they're a millimeter away, but they have to be pretty close for them to work. And if you lift something up in the air, um, there we go. It's getting no reflection right now, essentially. And I've got very little ambient light in the infrared. I suspect if I brought an infrared remote control and blasted it in there, it would receive some light, but I don't know if anyone's out to sabotage your robot with infrared remote controls. To give it a test and make sure you've got the right sensor on the right side, put your finger over top of the right sensor, and you can see my finger coming right in there. And you can see that the numbers on your code change. Now with the finger over top, I'm reading 1,000 on the left edge because there's nothing on the left sensor right over here. It's not getting any infrared light reflected back into it. So that's the same as being over top of a very, 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 very black line. But the right edge sensor has my finger underneath it, and my finger is a very reflective object because it can transmit the infrared light into there, and my finger bounces it right back into the sensor. So I have conduction across the phototransistor, causing a voltage drop across the 10K resistor, and as a result, I've got a very low voltage coming out here at the right edge detector. And if I take my finger and I swap it over to the other side right in here, well, there we go. I can swap those back and forth. And this is a good way to test and make sure that your detectors are working. Check with the camera to make sure that the lights are on, and then put your finger back and forth over top of them to make sure that they're working, and you should see those numbers change as you do that. Great. Well, what are we going to do with that now? Well, let's see how it works if we put it over top of a black dot. Now, take a piece of paper and put a nice big felt pen black dot on it. You might even be able to get away with using a really dark pencil mark, and just slide your robot right down over top of here. And if you get that sensor right over top of, it's got to be right over top of that black dot. And let's see, I'm seeing a slight reading on there. I was reading a couple hundred before earlier. I may not be sufficiently over top. Maybe I need a bigger, darker dot. There you go. Bonus points. You can watch Jason coloring on here. That's why there's a speed up function on the YouTube videos. Okay, let's make sure I get that. Okay, that's my right edge. Ah, there we go. Now you'll notice that the right edge right now is only reading about 270, which isn't quite as black as it was when it was up in the air right here. When it was up in the air, it was around 900. There is still some reflection taking place from a felt pen line. And that's why I like to look for really stark contrasts. And I like my blacks to be really black. So you can use a pen, but the pen seems to be reflecting things a little bit. If I just put it down on my blue desk here, um, I'm not quite sure why I'm getting different readings there on the desk. There might be a little bit of warp on there. If I push them both down to the same height, there we go. There's a little bit of twist right in the front of my Boombot right here. So twist that back nice and straight so they're reading about the same. It's important that you take a moment and get to know your sensors a little bit. Now, I brought home from the shop a big sheet of glossy white paper. The white should be super duper reflective. And then rather than using felt pen, I've taken some black electrical tape and I put black electrical tape down over top of here because the black really is a better black on there. And let me just try putting that over top of right there. And there we go. I'm reading 26 and 28. And if my sensor comes in right over top of here, and now I'm reading about 570 when I'm over top of that line, come back over the middle. And now you can see if I keep that tape in between the two sensors both read low, 26 and 24 I've got showing up down on the display over there. So that's a good sign. And if it comes over here, so one of the sensors is over top, it jumps up to, well, First I saw 300, then I saw 600. We're going to need a deciding number when we say, okay, how do we know if we're over black or over white? I'm going to say, just looking at that, I read so low when I'm over top of the white on here. Sometimes I'll get a reading of, let's see, when I'm all the way over, I get a reading of 300 or 500 or so. Put that right in the middle. I don't want to wait till I get all the way over. I want it to trigger a little bit sooner than that. I think I'm going to trigger on that right edge. Let's see, just move that over a little bit. I think anything over greater than 100, and that means that I'm over top of some form of black. Now, you can tweak this for the surfaces that you're working on, and I'll show you how we go about doing some of that. But like I say, electrical tape on some nice glossy paper. If you want to take some glossy paper home, let me know. But if you've got a nice white tile floor, doesn't have to be bright white. Even linoleum, kind of gray yellow, should work pretty well. Let me know, and you can take some of that home. So what are we going to do with this? Well, I'm going to add another constant in here because I may want to come back and tweak this a little bit. Okay, and I'm going to say const int black line equals, what did I say, about 200. And this is the number determined by testing to separate a white line from a black line. Okay, there we go. Put that back in the camera there. Okay, so now I want to test this. Now I've got my serial print statements right here. I'm just going to leave them in for right now. And I've got a really good way of getting instant feedback from the robot because I've got my LEDs on there, okay? And so we can do a little test right here and we can say if analog read, did I do that right? Analog read. How come I can't remember how to type analog read? There we go. See how it pops up? I do like the new IDE. Analog read of left edge. And in fact, if you don't feel like typing it all in, you can just type that in. And I can say, so if the analog read of the left edge is greater than the number black line, okay, then what do I want to have happen? I want to have digital right LED left. There we go. Comma high. Okay, so this means that if it's greater than black line, that means I'm over a black line and the LED will turn on. And remember that LED is going to stay on unless we turn it off, so we better add an else digital right LED left, comma low. There we go. So now that should work for my left edge sensor, and it should give me a warning of what it's over top of. I'm just going to copy that and paste it right in there. And then I'm just going to come in here and change all of this to right edge and LED right and LED right. Okay. And now this should give me a visible test right on the robot. I'll put a little delay statement in here just so I don't overwhelm the serial print statement with continuous serial prints. But I'll make it quite a bit shorter this time because I want to get quick feedback from the robot. Let's upload this right here. And as you can see, the new IDE uploads and compiles much quicker than the old one. And there we go. I've got two sensors on the front of the robot. And if I lift it up, they both turn on. And if I put it down, they both go off. If I put my finger underneath one, that one turns off right there. And if I put my finger underneath the other one, that one turns off there. So when I'm over top of a white line or a reflective object, the LEDs are off. And when I'm over top of black, then the LEDs turn on. Let's bring that little maze that I've made up right here. Let's see what happens there. Everything's. So when I'm sitting right over top of the black line, then both my LEDs are off. If I start to turn this way, that LED turns on. That means I probably want my robot to turn that way. And if I turn that way, I want that LED to turn on. Okay, that's a good way to test and see that this is probably going to work okay. My sensors are probably doing their thing. Alrighty, going well so far. Now, here's a little schematic diagram of our sensors right there. Turns out we took a look at that using Design Spark. We don't need to worry about that too much anymore. What we want to do right now is we want to come up with a little bit of logic on here, okay? And so what we're going to do is we're going to want to think about the possible conditions that we could have. Now, let me put a black line right down here representing our tape. Okay, and seeing as how I'm working on just writing this all out, let me just take this and make that a little bit bigger for you to see. Okay, so when light is reflected in here, right, we covered that already. We've got sensors right here, and this side is the left side. This side is the right side. And when our left sensor is right here and our right sensor is right here, that means that we're straddling the line, okay? And when we've got that condition, we want the robot to go forward. Okay, now we can test this condition because in this case, both of these would be over top of white. So both of these are going to be less. That number that I've called black line. Okay, so when both are less than the black line number, you want to go forward. Now, the line will turn off to the side, or your robot will start to track off to one side, and one of your sensors will come over this way, and the other sensor will come over this way. Okay, and now one of your sensor is left is going to be greater than black line, and right is less than black line. And when those two conditions are met, then what I want is for the robot to start turning to the left. Okay, because we need to bring that nose of the robot back over this way to get those both back over top of the line. And our final possible condition is that, the sensor is going to be right here. The other sensor is going to be right over here. And now in this case, we're going to have left is going to be less than our black line, the black line being the differentiating number that could vary depending upon the surface that you're using. So you might have a different number for black line to run on your floor or your board than I do. This works great with a piece of paper that I've got right here though. Left is less than the black line. and right greater than black line, then you're going to turn right. And excuse me for just a second. I think somebody's calling to tell me that Microsoft has attacked my computer or that the Prince of Nigeria wants to give me some money. Okay, we're back. It wasn't a Prince of Nigeria after all. It was actually a human being on the phone. Um, Neighbor with a question about the electronics on the 1982 Vanagon that he's restoring, and my concerns about what the German engineers did in 1982. And anyway, um, let's just say I think you need to have a lot of passion and love to restore Volkswagens. Okay, so back down here, we came up with three situations that we want to take a look at. And so we want to integrate that into our code over here. So let's just come in here and I'm going to get rid of that delay statement for right now. I'm going to leave all the rest of the code the way it was sitting in here. And I'll take a look at the first line of code and then maybe I'll leave it so you guys can take it from there. So here's our first situation. So if both are less than the black line, I want it to go forward. So I'm going to say if analog read left edge is less than black line. Okay, now that's one set of situations right in here. So I'm going to put another set of round brackets around that so that it does that calculation first right in there. Okay, and you can see that a lot better if I shrink this down and move it back to the side over here. There we go. This is what I was typing right down in here just a minute ago. So if analog read left edge is less than black line and these brackets are right together. So that's one Boolean condition. So I'm testing the left edge right there. And then I'm going to put a logical AND in here, some more brackets. And the analog read of the right edge is less than. Okay, then what we're going to do is we're going to drive forward, comma. Now, it's possible that you don't want to go at full speed. You'll have to try this with your robot because you're going to have to work on your timing, and there's a lot of tweaking to get to get line following working just right. But that's how I'd set up my first condition right on here. And then you could set up another condition on here for when you're in this situation and you want it to turn left, and another situation where you want it to turn right. And really, you've only got three different things that your robot can be doing in this situation. If you're doing a white edge, or sorry, a white line on a dark surface, say white electrical tape on a blue or black table like that, then you're going to have greater than signs instead of black line on there. Okay, so go ahead and see if you can figure out what the rest of the lines will look like. When you're all done, it should look something like this. Okay, here we go. And, oh, too fast. Come back here, you little thing. Okay, so like I said, you maybe don't want to run it at full speed, particularly for going around some of those corners. You'll notice I added another statement in here so that if they both read black, it turns them all off on here. So you can see now I've got if this side's reading white and that side's running forward, that side's running backwards. So it will be turning that way because that side's reading black. I want to get it off the black. Turns the other way. And if they're both turning white, then they're both running forwards. So if I put it down like that, it's going to head forwards and come back here, you goofy thing. I'll bet that looked good on video. Um, so let me tweak that a little bit and see if we can get it following those curves a little more tightly. Okay, here we go. Fix number one. Give it a try, and whoa, still too fast. Okay, for these particular sensors, okay, with a bit of tweaking, here we go. Oh, look at that. Look at that. Around that curve. That's a tricky one for it to follow down into this corner. Oh, doesn't quite make it around the last turn. Okay, that last turn is just a little bit tricky over there. And I've got some fairly tight radius corners in here. So I've had to slow it down a little bit. Now, one of the reasons I've had to slow it down, of course, is because when you've got any mechanical system like this, that one actually just came to a stop right there. I'll get around there. When you've got any kind of mechanical system like this, there's momentum in the mechanical system. So when you start traveling really fast, you can't always respond fast enough. Your motors don't have the acceleration necessary to control what it's doing. So anyway, there you go. This is line following. You use your two little sensors right down here to tell you whether or not you're over top of a line, and then you put your robot down on there and you start going around. And you can actually make a little bit of a race out of it by, obviously on a bigger board, you can have, one person start on that side, one person start the robot on that side, and see who catches up to the other, and that'll tell you who's got the most efficient code. So anyway, take a while and tweak your code a couple different iterations, and don't try to go around ridiculous 90-degree corners or really tight radius corners. Okay, you can see that even down here where I've got a little bit of a ripple in the tape, it's a bit hard for it to get around. More complex edge detectors will have more than two sensors on it, and that allows you to make things go a little bit faster and with a little bit more control. But for our Boombot, two sensors is enough to get the idea of using the edge detectors for line following. All right, congratulations. Looking forward to seeing your video when you're all done this. Upload a video of your robot going around and following lines, and let me see you do some corners in both directions.